Thank you so much for the invitation that you've given to me to be with you all today, right, for the session on design and analysis of algorithm. Right? Hello? Hello? Okay. Okay. So, uh, now you're all into your which year? Can I have your names on chat, students, and which year and which stream you belong to? Hello, I'm audible. All right. And once again, good morning to all the students. A special thanks to Omna ma'am, the entire team, Indra ma'am, for having invited me. Am I audible? Is my voice audible? Yeah, thank you so much. All right. So, can you put onto your chat, right, from which your name and from which department you belong to? Quick. Your name and which department and which year you belong to. Your short name. Students. Yeah. I'd like to have it as an interactive session. Thank you so much. Others, you can put it onto the chat. That's also is fine. Thank you, Aditya. Because when you come to this online mode, this is one of the best way to interact with each other. All right. Yes. All right. So let's move on to the session on design and analysis. Thank you, Kushal, Ramjam. All right. You're all from AI, ML, robotics, right? So Manasa from cyber-physical systems. Good to hear from you all. All right. So today's session, we are going to see about design and analysis of algorithm. Thank you, Shah. All right. I don't know, somebody's mic is on. If it could be. Okay, Saurabh. Thank you, Saurabh. So it is like you have been learning the design and analysis. I think almost you would have learned you are halfway of your subject, right? So today we are going to see majorly not more on to the algorithms, how we are going to apply the algorithms onto your lifetime, right? So thank you, Bible. Thank you, Tamilarasan. Thank you, Abram. All right. So let me share my screen. All right. Can you enable me to share my screen, please? Okay, how are you all doing today? I wanted to just one word. How you are all doing today? How are you doing today? Thank you, Mangi. Almost you're from third years, your final years, but most basically from AI and robotics department. How you are all doing today? Can you allow me to share, please? Omna ma'am, Indra ma'am. The share is disabled. Can you please allow me to share? Sure. No problem. Yes, please, others. How are you all doing today? All right. So how many units you have seen in your design and analysis of algorithm? How many units you have seen in design and analysis of algorithm? And what is that you liked, or one topic that you like the most in design and analysis of algorithm? You can put it onto the chat. Like one topic you like the most. Yes, please. Yeah, I'll check now. Yeah, I'm allowed. I'm allowed to share now. All right. You're able to see my screen, students? You're able to see in my screen? Yes, type Y on the chat. No type. Yeah, thank you so much. So today we are going to see how many units you have completed. Can anyone of you unmute and speak? How many units you have completed in design and analysis of algorithm? How many units? I know I've got a syllabus, so you've got full of 5 units. How many units have you completed? Yes, no, type on the chat. All right. Am I audible? Can one of the students say am I audible or not on the chat? Audible, type Y on the chat. Am I audible? Hello? Am I audible? All right. So how many units you have completed? Yeah, most of you have given yes. But how many units have you completed? 4 units you have completed. Thank you, Manasa. So I know you have taken by and large. So today we are going to see just an overview of it. And I want the session to be an interactive session. I want your inputs from your side so that we'll be able to journey through. Okay, before I start, can you spot a mistake on this image, please? Can you spot a mistake that you could see on this image? I'll give you 15 seconds. What's the mistake? What do you see on the image? What do you see on the image? Quick answers. We have got just 1.5 hours and we have to complete it fast. Yes. What do you see on the picture? Can you find what's a mistake on the picture, please? Hello? Anyone? Anybody can say. We have like 50 plus students are here. Can you please? What do you see in the picture? 15 seconds is done. Can you tell me? Balloons are flying in opposite direction. Yes. What do you see? A rainbow. What's a mistake? Thank you, Aditya and Lokesh. What's a mistake? You can feel free to unmute and speak. No problem. Anybody? Not even one? Aditya, can you tell me? Aditya? Yeah. Thank you. So the rainbow color is a big round of applause to Aditya. We have violet, indigo, blue, green, yellow, orange, and red, the Vimsha color. But here you see it has been interchanged. That's the mistake. Yes. How many of you found the mistake? Can you click raise hands? The color, it's like violet and indigo are given like indigo and violet. How many of you were able to figure it out? The change of color. Can you click raise hands so that I can see how many of you raised hands? Yes. All right. So because I can see Aditya and Shobham, two of them have raised their hands, right? So if you could see to it, because you know the fact, okay, the design is the rainbow, and you know the facts about the rainbow. It starts with violet indigo. Because you know the facts about it, you were able to find out that's a mistake, right? So here you know the design of the rainbow, and you've done an analysis because I've asked you the question, what's the mistake? All right, so you are able to figure it out because you know the facts. You are able to find it out. So what processes your mind is analysis of the situation that is given. All right, it's the analysis of the situation. So now, so this is what happens in algorithm. All right. Can one of you put it onto the chat, or can you unmute and say, what does algorithm means? What is algorithm? What is algorithm? Just in one word, what is algorithm? It could, I don't want predefined definitions, just what is algorithm? It's a procedure. All right, thank you, Prana. It's just a procedure how you follow up the procedures, right? But the subject that you're going to learn is a very, very interesting subject, right? That's a design and analysis of algorithm, right? The procedure is the same. How many of you know cooking? How many of you know cooking? Yes, no? Type Y on the chat. If it is no, type N on the chat. All right. So I'm almost, I at least can say you also know at least to do how to Maggi noodles, the 2 minutes noodles. Yes, no? You all do, right? Some kind of cooking, right? And something that you do, if two of them are going to do maybe the procedure is the same, but the outcome are not same. Imagine you cooking and your mother cooking. Whose cooking is better? Which will be tasty? The procedure is the same. Which will look tasty? Which will be tasty to eat? Your cooking or your mother's cooking? Answers on chat, please. Or unmute and speak. Any one of you whose cooking would be good? Yes, please. We have got so many. 57 people are there. Kindly do answer. Generally, it is your mom's cooking looks better, right? It's tasty. Maybe the procedure is the same. After you taste it, you see that's better. That is analysis, right? Though algorithm is something is just a procedures, but analysis is what out which is better or which is good. All right. Which is good. So, like, thank you, Lokesh, for answering. She said, moms, the procedure is the same. But here in this paper, you're going to see about the design and how do you analyze your algorithms, right? Algorithm step-by-step procedures, right? What are the applications that you are using, right? So, you know, now we are more into the digital world on mobiles, right? You are using so many applications, right? Today from morning till now, I know so many of you have so many applications. Can you relate to any algorithms that you learned in this paper of 4 units that could be applied onto the applications that you've used? All right. Audio is not that much clear, but rather, thank you, Vivek. All right. So today we'll be seeing, so design analysis starts with the design, then you analyze, then you implement, then you experiment, right? You design, then you analyze, right? Then you implement, then you experiment. So this is the first stage. Taking into a real life example, very simple. How many of you have bought dresses in shops? Stitching, you go to a tailor, give him a design, you stitch it and get it? Yes, no? Yes, maybe it could be shirts or pants. It could be churidars, it could be dresses. So first step, you design what you want to go, right? First you design the tailor and you design what dress, what. Then you analyze whether it will suit for me, whether I want to have a full hand or half hand. Then you give it to the tailor, he implements it. Then you go for a trial basis to experiment. If it is not fitting, again you ask them, the cycle keeps going. Very, very simple example how you go to a tailor, give him a dress and ask him to set it up for you. All right? Able to understand, and same thing it works here in your algorithms. As you said, algorithms is a set of procedures. Here we are going to see what are the different algorithms and how things are going to work on with that. All right. So, design and analysis of are you able to see my screen, please, everybody? Able to see my screen? Just click a react. Yeah, thank you, Aditya. You're able to see my screen. Alright, so design and analysis is a fundamental concept of computer science. Though you belong to AI and robotics or any different kind of streams that you belong to, that's fine. But your heart of your engineering is your computer science, right? So creating efficient solution to majorly for different computation problems, right? As we journey through, I'll be sharing about some of the basic algorithm techniques and then how it is being used, what algorithms are used in Amazon and so much and so more, right? According to the time, we'll see how it works. And evaluating the performance. This evaluation is very, very, very important. Without evaluating, I always say DAA or design and analysis of algorithm, it's not a perfect thing, but right, it's not like perfect, like this algorithm is the best suited solutions, but here you're going to give them a range of algorithms, right, that could be more easier or which could be most appropriate, I could say, right. Generally it is not the perfect one. Then using this you're going to give an appropriate, right, an appropriate solution to it. So DSA, the design and analysis of algorithm, that's a focus on designing, right, addressing specific challenges, and here you're going to analyze the efficiency of time and space complexity. Can any one of you say what is time complexity and what is space complexity? From your understanding, just in simple English. Yes, please. Or you can put it onto the chat. Time complexity and space complexity. Let's be quick. Okay, before that, do you want to have an active session or a passive session? Active session is I ask you a question, you're responding. Passive is only I'm speaking, you don't respond. Yeah, it's a time thing. Thank you, Manasa. Right? Time complexity is the amount of time taken a code to run. Space is how much space it occupies, right? The memory allocations, right? And so much and so more. Thank you. A big round of applause to Manasa for the quick answers, right? So here you're going to consider when you design an algorithm, right? I said it's not always perfect, but it's only approximates that you're going to give, taking care of time and space complexity. This is a very, very important computational complexity, right? That's most students, right? I was into teaching it a decade, right? Excuse me. Right? So here, generally students, they don't like the subjects, right? Because it's more of theory, but you know, this is the heart of, and once you love understanding the subject, I say this is one of the easiest and the most beautiful subject, right? Without algorithm, nothing works. Even when you get up in the morning, when you brush your teeth, there's a procedure how you brush your teeth. All right. So everything, how do you design to it, right? Even some people brush faster and some of them are very slow, the way you take, but everything has got different procedures. Here, this algorithm all focuses on your computation. Say for example, if you're going to take a big data analytics, right, where you work with GPUs, TPUs, so much and so on, there's a bigger concept called scheduling. right? How do you schedule? How do you allocate the resources onto that? For that, majorly this algorithm works. Like big companies like Google, Facebook, Amazon, right? Where and all they're using big data analytics, different algorithms are being used. All right. So determining the amount, and what is this analysis? Determining the amount of time and space executed to required to execute it. Say for example, very simple, you write your exams in college, right? What the college does, they find it out, right? Who are you, where are you, and then they try to allocate, all right, the resources. This room is for this person, this room is for this person. If a room can accommodate 60 students, how many they'll be able to allocate? Only 60. Even 61 cannot be allocated, right? So that's what here we are going to see about time. So the time complexity takes care of the time required. Space, it's the memory that is required to execute. Anybody here has worked on a Hadoop? Anybody has worked on Hadoop? Do you know about Hadoop ecosystem? Yes or no, please? I want quick answers. Yes, students. Have you learned about Hadoop ecosystem, the big data analytics using Hadoop? Type either Y or N. Y stands for yes, N stands for no. On the chat. Am I audible? I hope I'm audible, right? Yes. Have you learnt about it? Yes or no? Aditya gives a link. So there you see you have got slave nodes, like the master nodes, slave nodes, the name nodes, the data nodes, right? There, heard of it. Thank you, Shona. There's a lot of applications, right, that works of with that without the algorithm that you cannot work. Time is counted for each statement. It is counted for variables and input and output. Here, the size of the input determines. I'll show you the complexities how it has been computed. And primary determinant is the auxiliary variable size. How much size? What is the size for integer? What is the size for float? I hope you should have learned the data structures, right? So, and deals with computational time with the change of size of input. How much extra space? Here, it's not the input. What is the type of variable? This focuses on the time taken to complete. This focuses on how much memory or space that is allocated. Is it clear? The time complexity and space complexity? Yes or no? All right. This focus on time. This focuses on the space. So if you take the big O complexity chart, right? So what is theta 1? Big O of 1 is a constant value, right? So when you see this green color, this is excellent. Big O of log n, if your complexity is going to be big O of log n or big O of 1, all right? So if it is going to be big O of n, it is good, right? And it is fair, all right? And if it is n log n, this sector, it says to be bad. And big O of n to the power of 2, 2 to the power of n, or n factorial, when your algorithm is of this space, which means it is taking more of the time to execute, or it is taking more of the space to execute your application. So here this graph, right, this two variables, right, these two complexities are most excellent, and theta big O of n is fine, right, it's good. But as you journey through, if the operations are more and if the time is going to be more, then it is not a very good algorithm. This is what you generally do in design analysis of algorithm, right? That's what, it's very simple if you know the structure of it, right? Now if you're going to see, if it is going to be constant, big O of 1, right? So hashing same amount regardless of the input size. Like this is okay. When you see to this, big O of n is 1 is okay, and big O of log n. So big O of log n is a logarithmic phrase, right? It's larger size. Generally, you would have learned about binary search algorithm, right? So that's fine. When you take a linear algorithm, big O of n. So big O of n, that's also fairly good. Here you can see big O of n for depth first search, breadth first search and linear search. These are the popular algorithms that you get linear, big often, cost increases at the same time as input increases. Then when you go on to the previous one, this bad one, right? Big of n log n, it comes with merge sort, quick sort, because the depth of the recursive call is logarithmic. All right, and when you take polynomial quadratic, we go of n square, n cube. That's a popular algorithms of bubble sort or dynamic. We'll be seeing about these algorithms, right? Dynamic programming, right? Or it can be both breadth first or depth first. If it is of n square with substrings for search, then the inner loop, then it is little bad because it takes more time. If you take exponential and factorial, right? If you see to it, then the computations of this traveling salesman problem is more, then it's but at low, it is of a lower cost, low time, right? Able to understand? So this is more acceptable. When you change the design of the algorithm, the complexity you can change it off, right? That's what we are going to analyze your algorithm. So I've given here like binary search, depth first, linear search, breadth first search, merge sort, quick sort, bubble sort, dynamic. What are some words that you understand from this slide? Just put on to the chat. What are the words that you can understand that you've experienced from this slide? At least this. Can you have it on chat, please? From the slides. Yes, please. Yes, no? What are the things that you've heard of it? All right. So this is worst, this is best. This structure is very, very mandatory. You need to know when you learn this paper. Big of one, you remember this. Big of one, big of log n. This green one, that's an excellent one. That's the best. Consonant logarithmic. Linear is okay. And then after that, it's all worst, right? N square, cubic, polynomial, exponential, and factorial, right? Worst to best, best to worst. You able to understand? All right. So when you take selection sorts or different sorting algorithms, right? So you can see n square for selection sort, which is quadratic, and if you could see n to the power of 2, it's onto the different phase, the horrible phase. So this is about the insertion sort. What is best case, average case, and worst case? Can anyone of you say what is best case, average case, and worst case? Best case is, say for example, very simple, right? You search for something. Maybe you search for a clip or you search for a needle. You go to a first place, you first itself, you get it, then it's okay. I can share my experience. Yesterday, I was searching for a needle for the thread, right? I was searching for the needle to stitch it, right? Generally, I keep things a little or more organized. I was not able to find. If I go to the first place under my cupboard, if I have found the place, that's a best case, right? No more iteration. I hit it on the first, right? But I went to like 7 to 8 place. Only in the 8th place, I was able to find it out. So if you're going to get it, if your iteration is going to be the more number of iteration, it is going to be worse. Say for example, it is going to be 15th iteration, you're going to find the thing that you're going to search, that's the worst. Say for example, if it is the first or second, it's the best. Say for example, if it is going to be 7th or 8th place, you're going to find it out, it's an average case. For in my example, yesterday was an average case. I think I saw it on the fifth or sixth place, right? I was able to find out the needle where I kept. So here, that's the best case, average case, and worst case. But by and large, if you see, you don't have a much of variations, right? Much of variations here. So this is about the best case, average case, and worst case, right? Can log in. So worst case, you see, the time is more and the complexities are also more. Able to get it? All right. Why the analysis of algorithms is important? This is important to predict the behavior of the algorithm is going to. So now here, from these 4 examples, can you say which one is better? From the best case, which is better? I showed you this, right? Big of big of 1, log n, big of n, n log n, right? Can you tell me which is better in this case and which is the worst in this case? Answers on chat, please. If you don't respond, I think that you've just logged in and you've gone off. From this slide, from the choices given on the best, average, and best, can you tell me? Quick sort is the best. Thank you, Anita. Quick sort is the best, right? And the best one you see, Bobo sort is of big of, infinity we don't, and these are all best. Thank you so much, right? So that's what very, very important to understand, right? To have a perfect, simple measures of how it is going to work, and it is impossible to predict the exact behavior. That's what always in design and analysis of algorithm, you've got best case, average case, and the worst case, right? Thus, I told, right, it's just an approximation, it's not perfect at all. You just approximate it. Even these notations, whatever we give, it's just an approximation, and it will say how much far it will be better. I told you, best case, you search the first location you get, then you get at the middle of the location, it's average. At the last, if you're able to find, that's your worst case. Right? You see all this, the time is increasing, right? The time will be, there's a difference in time how you fetch your objects. Right? So these are different sorting algorithm complexities, right? You can see these are all even for best case. Then in general, they say best case, average, and worst case. Not on one if the data size is small, if the data size is average, if the data size is large. Able to get it? So this is how the complexities have been computed. We go off 1, we go off n log n, and again is better, and but it is going on the exponential form of we go off n to the power of 2, n to the power of 3, and in factorial those are not much recommended space complexities because it's more burst. All right, able to understand till now what we have seen? If you're able to understand, type Y on the chat. If not, type N on the chat. Thank you. Thank you. You're all very good silent listeners. All right. Thank you so much. So now we have started with what is space complexity, the time complexity, and which is much easier. But this slide, never forget, when you are also going to design your own algorithms, maybe in for your final product that you're going to develop, this should be the analysis that you need to do it. See, nowadays people say, because I was into teaching for a decade and then I started this company that's Computational Intelligence Research Foundation, where we work on research, development, education, and training students. All right. And here, many students I see, when we started working with machine learning algorithms, I remember running my SPM for more than 15-20 days, from starting from coding to implementation to error debugging. Now you get your ribbon support vector machine. So whatever algorithm you go to Skykit or whatever the application, so GitHub, you get it and run. The way that you analyze is very important. This, if you want to take a screenshot also, you can take it. When you learn design analysis, it's not what is given the subject that you need to write and get your marks and go. That's not the objective. That's all. When you are going to develop, you are all tailor-made engineers, right? When you are going to develop your application, right? It could be your own algorithm. Then you have to analyze your algorithm, the best case, average case, worst case, with small data set, the average data set, and the large data set. This is very, 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 very important. All right. So now let's move on to the algorithmic design. Right. So we have divide and conquer methods. It's a top-down approach. Can you, before I move on to the next slide, Can you give me some examples of divide and conquer algorithms? What are the divide and conquer algorithms that you've seen? Yes, exactly right. Thank you. Others? Yes, please. On chat also you can give. All right. So you have a merge, or a big round of applause to you, right? And the binary search is the divide and conquer method, the bubble search algorithms, right? The quick sort, min-max analysis, Schatz's algorithm, the closest pair of points, and Krapsupa algorithm. These are some. There are many more, but these are some of it. If you see on the merge sort, right? You see it is right n log n. Can you see it? So how it is calculated? Say for example, I have one big problem. I have to solve the problem. That is saying, I'm divide and conquer. I'm dividing n by 2, n by 2, and then I'm dividing n by 4, n by 4. So 1, 2, 3, 4. Then I'm dividing the 4 by 2. Then 1, 2, 3, 4, 5, 6, 7, 8. So 8 by 8 it is n, right? 4 by 4 and 2 by 2 and n. All right, but after that I'm going to have 1 by 1 and 1, 1 and 1, 1 and 1, 1 and 1. So if I'm going to calculate this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16. So n divided by n log n. So complexity. Able to get it? Yes. In general, there are so many algorithms. It's just the skeleton of divide and conquer methods. You have to understand n divided by n log n. So then when you come into the next algorithm, that's a greedy technique, right? You know what is greedy technique, right? Sometimes you go uncertain to a function, then you're allotted some tasks to do it. You're not predefined. You just go, they come. And sometimes it happens in colleges. You come, can you do this work? Can you go get it done? It's not predefined. Whosoever comes, they're able to do it. Sometimes it works, but sometimes it doesn't work. All right, that's a very, very simple example of greedy, right? It is used to solve optimization problem, right? One, when it is given an input task which is required to be either maximized or minimized, knows as their objective function. This objective should be very clear in any application, that if you take a traveling salesman problem, what is an objective? Minimizing the time or maximizing the time to reach all the parts? What's an objective function? Minimizing or maximizing? I don't know why you don't answer. Kindly do answer on the chat, please. You want to minimize the time that the person travels, or you want to maximize the time? Yes, please. You have to minimize the time, right? But that's not always guaranteed. Right? The applications of greedy algorithm, the CPU scheduling, right? I told you, right, when you take big data analytics, lot of see 1 minute, how many videos are watched in YouTube? How many 1 minute, how many Instagram reels are watched? How many Snapchats are uploaded? Right? How many emails are sent? How many Google searches? It's so much, and it has to schedule, right? So the applications are the CPU scheduling, the minimum spanning tree, that your MST algorithm, Jigsaw, the shortest one algorithm to reach, the fit algorithm, first fit, best fit, yes. So on memory management, then the traveling salesman problem, which, but that's it, minimizing. It should be minimum of the making all the routes, right? Knapsack problem, Egyptian fractions, and the bin packing problem, right? These are some applications of greedy methods. methods. So when you take history of greedy method, the greedy was first coined by the Dutch computer scientist called as Edser W. Dijkstra. Right, he wanted to calculate the minimum spanning tree. So what he started, he wanted to use a graph-based problems, right? So what we started, this greedy started coming into picture from 1950s, right? And then the scientists Prim and Puskar also achieved the optimization of minimizing the cost of graph during that decade. And then when it comes to 1970, an American researcher proposed a recursive strategies, right? So when you make it more recursive, the greedy is for solving problem. In 2005, it's I know you know right, NIST records, right? They were making a different optimization algorithm, and it has been extensively used for open shortest path first algorithm when you'll be learning it in computer networks and for packet switching protocols algorithm. So let's consider this problem now. A container to be loaded, right? There's a large ship with cargo, right? And the cargo has containers of equal size, but each cylinder is of different weights. Each container is of different weights. So I have to load this to my ship, right? That cargo always it's of equal size, but the weights inside. So cargo with maximum number of containers. So what is my objective? My cargo capacity is CP. All right, the capacity of cargo is CP, and we need to load the containers in the ship. Right, we need to load the containers in the ship in such a way the ship has maximum containers. Right, so I want to push more containers to the ship. So here it is maximum of, right? Maximum is this is what you need to understand, whether it's maximum is objective function, or there when you take traveling salesman problem, you have to reach all the paths with minimum time. That is minimization is your objective function. This you should be making it very, very clear in your mind. For example, if I'm going to say there are 4 containers, the first container is 20, the second is 60, the third is 40, and the fourth is 25. Right? Let's keep my CP weight. What is CP? The cargo capacity is 80. What is my objective? I have to put maximum cylinders or maximum containers to it. So what I will do, first is 20, second is 60, 40 and 25. If I'm going to put my second container, it is going to reduce, right? Only one more cylinder only I'll be able to do it, right? So I'm going to sort it. Here comes your sorting algorithm. When you sort it, what will be first? 20, first one. Next is 25, the second one. Third container 40, and fourth is be my second container. So, but only maximum is 50, so 80. So I'm going to put my C1, that is 20, then C4, that is 25, and last it is 40. So this is can you understand why do you learn this algorithm in all your cargo loading or in Amazon searches, in Flipkarts, right? Sometimes when you see, when you book some products, it will be delayed because it will drop other passengers and then come and pick it up, but the price will be little less. All right, so all these applications that you're using, Ziggy, Zomato, Amazon, Flipkart, whatever it is that recommend, or many of the algorithms that are arising, whatever you learn, you need to think, you have to apply. First, understand the algorithm and try to apply with real-time situation this algorithm works. Able to understand about this greedy algorithm? Yes, no? Yes, type Y on the chat. N, type no on the chat. To know how many people are really connected. Quick, please. Thank you, Aditya and Pragnaya are the most active members, right? Yeah, thank you, Manasa. I don't know what about others. All right. So this is how now you're able to realize, understand how can you apply the sorting algorithm and which sorting algorithm could be the best and how you'll be able to load the cargoes onto the ships. All right. So the next we have seen about divide and conquer, and the second we have seen about the greedy. The third we are going to see is dynamic programming. You can have it as a bottom-up approach or a top-down approach, right? So when you use a top-down approach, it is memorization, If it is bottom up, it is stabilization. That's the major difference. What is stabilization? State transition relation is difficult to very well think from which state to which state it goes. But here it's very, very easier, right? In memorization, the code gets complicated when lot of conditions. Here the coding is easy. But here it is very fast to access, but it's very slow here, right? If sub problems are to be solved at once, a bottom-up approach dynamic should outperform their top-down approach. But if the sub problems need not to be solved, right? If it is to be solved or need not to be solved, then you move on to this method. In tabulation, starting from first entry, all the entries are filled just one by one. Here you can just all the entries are in the lookup table or need not to be filled. Everything need not to be filled in memorization. So can you see it is bottom-up approach, right? Like you see DFS, depth first search, breadth first search. So Fibonacci 2, 0 and 1, Fibonacci 3, 2 and 1, Fibonacci 4, right? And then Fibonacci 5. Right? So either it is bottom-up approach or top-down approach on your dynamic programming. All right. So the next is branch and bound algorithms, right? So it has to be divided at least two. When you have a problem, that can be at least put into two sub-problems. All right. So when you take branch and bound algorithms, it is all for global optimization, non-convex problem. This is very, very important. It's a non-convex problem. It can be slow. However, the worst case, it requires to grow exponentially. But if you are lucky, you get it at very less effect. We don't know about it, right? It can, and that's what every algorithm, you have a best case, the average case, and the worst case analysis. So I'm going to take my first level. I also told that branch and bound will be work only if we can divide the problem at least minimum into two sub problems, right? So I have a job. I'm going to have A equal to job 1, job 2, job 3. The job is 18, 12 and 16. So I'm taking the minimum one, so 12. Again, when I come here, again I'm splitting my job into B job 1, B job 2, 12 and 17. I'm choosing my 12 and then I'm going to my C17. So this is an example of branch and bound. All right, branch and bound. Able to understand? Yes. So we have seen divide and conquer. What was the second one we have seen? Greedy method. Then we went to dynamic programming. Now into branch and bound, right? Now we'll move on to backtracking. What is backtracking? Until we find the right one. It's a depth first search algorithm, right? So during research, if there's an alternative does not work, the backtrack is the choice point, right? So you can again backtrack. So from the start node, I go to A, it's a dead road. So I become from there, I'm going to see that's dead. D again dead, F again dead, only G I'm getting a success node. This is how you push your packets, right? Your emails from one node to the other, right? So when you take backtracking, it is depth first. When you see branch and bound, it is breadth first. It is search order. Can you see it is depth first? It is breadth first. All right. Branch and bound is breadth first. Backtracking is depth first. Execution time, it's more. Here execution time is less. When you take the space, it is using stack. Space is less in backtracking, and the space complexity is more on your branch and bound. All right. So it depends either a maximum profit or a least cost. It depends on that. Backtracking, never find a solution if the depth of the tree is infinite. If the depth is going to be infinite, then you will not find the solutions. This is first and first out. Finds the solution closest to the root in branch and bound. Right? Least cost branch and bound directs the search to the place where you can look so quickly to get the answer. Able to understand till now? Starting we saw about the complexities. Then we moved on to 5 algorithms: divide and conquer, greedy, dynamic, branch and bound, and backtracking. So we have completed 2 segments of it. Any doubts till now? Yes or no? I think you are very, very inactive. Can you give some quick answers, please? Okay, thank you, Shoham. Thank you, Aditya. Only 5 to 6 quick in answering. Thank you, Vivek. Thank you, Vivek. All right. Okay. Now, now I want you to see. I want to ask you all a question. I hope everybody you buy products from Amazon. Can you put on to the chat what's the latest product you bought in Amazon? What's the latest product you bought? Amazon or Flipkart or whatever it is. Yes, please. Any new product that can be discussed? You bought it on Amazon or Flipkart or anything, Meesho, Washo, whatever it is, Swiggy, Zomato. Nobody buys it. You don't buy anything. They buy or don't buy. All right, I don't know. All right. So I'm going to take from Amazon. So Amazon, their major objective is what? What is their objective function? I told it maximum or minimum. Maximize your sales by optimizing, isn't it? So the objective is to maximize their sales. So the factors impacting the product ranking is here. They use A rank, 8 and algorithm. Do you see the reviews and rating before you buy? Do you see the reviews and rating? Yes, I think it's definite yes, right? Without reading reviews, you don't buy, so that's an influencing factor. The price. We are very intelligent, right? We go to Meesho or any different apps, we go to Amazon, we go to Flipkart, and then we decide upon it, right? And also when you book Uber and what is that? Uber, Ola, or what is Zepto, Rapido, whatever it is, right? Before you order it, you check in all the three and which is the minimum cost. So there the objective is minimization is a function. So you see the price, whether stock is available or out of stock, back-end keywords, what keywords people use to search, the images of the products, right? The keyword, how relevant is the keyword, right? How is the conversion? Did you put it into your wish cart and how it is converted? What is the sales history? What's the impression? How many impressions are made? Click-through rate, right? So these are the different factors, elements that are used to maximize the sale, right? So the latest algorithm is A10 algorithm, right? That is used in Amazon. So they use seller reputation, the quality of product, the external traffic, clicks through rate and sales and revenue. So these are the major facts that they have taken, right? These are the major facts they have taken. Any able to understand? Yes. Able to understand A9, A10? All right. I'll give you 2 minutes. Can you search and come what algorithm Flipkart is using? Yes, what algorithm Flipkart is using? Amazon, I told you, A9, A10. To maximize the sales. That's their objective functions, right? Yes, I'll give you. Now it is 12:42. Let me give you a time. 2 minutes. Find it out and put, at least this I want you to do. What algorithm Flipkart uses for its search? Yes, yes, please. What algorithm which is used to maximize research? Answers, please. You got it? Yes or no, or you're trying? Yes, please. To maximize research. Collaborative filtering algorithm. Thank you, Aditya. Yes, collaborative filtering algorithm. The factors are almost the same in Amazon. The click-through rate that makes that's very very important, right? Which is a collaborative filtering. Yeah, it could be others. Are you trying? They do the research whether they sell a good product, and then they see how it is. The factors are very very important. That yeah, matrix factorization. Thank you, Manasa. So now we're able to understand the algorithms that you learn, how it is applied onto your real time, even without knowing that, right? Even the recommendation systems on YouTube, the Netflix that you use, all right, the Spotify, right? Whatever the algorithm, the design that you've learned is all, try to apply whatever you learned, right? That's what I always tell students, right? It's not only the theory subjects that you learn, try to apply. So the string matching algorithm, right? You know, when you see control, find and replace, what algorithm runs behind, right? At CIRF, we have like internships, right? Students come for internships, and we train the students, and they develop products, some are into research publications, so some are interested into research and something, right? Like one student did a very, very, I told during the introduction session, right? So you can, we make them to do a two mini project and one major project, right? Where they come for like 3 months, they come and stay with us, and one student beautifully did this, right? It's not much related to string matching. You can give. I showed him a demo of using Python programming, how a package was used. I can give a text and then it works to find, and how so simple. We see that control C, right? The control F, find and then you replace it. Then he took one, he took a package of the same, right? He says, "Hello, how are you?" And he generated is almost 30 different languages, right? You can choose like characters, like if it is English, EN, Tamil, TA, and so many different. He has given the code. Once the string searches with that language, the entire text given is translated. You can relate it to the Google Translate that you use, and that was done as a very very small project here by the students, but not converted into a web application because they stayed for a very very short time. So the string matching algorithm works in many different applications. Even when you search your contacts, use your mobile to search contact. How do you search your contact? You type in their name. All right. As and when you type, you can see there's a filtering mechanism that happens here. So that is where this algorithm works, exact string or approximate string matching algorithm. It performs time efficient tasks in multiple domains, right? So exact string matching, right, finds one or several occurrence. When you have run Python, you know how to find the one occurrence or multiple occurrence. Right, further classified into algorithm-based character comparison, it is uppercase, lowercase, all right, deterministic finite automata, right, of DFA method based on bits, right? Every character has an ASCII value, right? And hashing string matching algorithm. The name base is one of the very, very easiest one, right? Where you check all possible replacements, right? And here you just run a loop and find whether until the search is found, right? North Morris Patch KMP algorithm, right, is actually where we go off N. right? We go off n by avoiding comparison with the elements of x. So this is how the algorithm works, right? A A B A A C A A B D A A B A B A. So my pattern that I want to search is A A B A. So I get it on the first occurrence, then I get it on the ninth occurrence, then I get it on the 12th occurrence. Can you find it out? Yes. So for this is the logic behind KMP algorithm. All right. So and Rabin Karp string matching algorithm, as well as for M characters, right? Character sequences. If the hashes are equal, then you get it. So this is how it works, and the complexity is big of n minus m plus 1, right? So and strongest expectation is big of 1, that is constant. That comes under your best case. So Rabin Karp algorithm AAABA. My pattern is ABD. So I'm not finding them. I'm moving the window. I'm moving the window. I'm moving the window. Moving the window. At last I'm finding it in occurrence 50ABD. Can you find the string and the pattern? This is a Rabin Karp algorithm. The next is approximate string matching algorithm, that is fuzzy string, right, or substring. So you have a text, you have a pattern, then it finds it out. Like document 1. So here it is decomposing, divide, and then finds a string matching algorithm. And what is the application of the string matching algorithm? When you write your research papers, you you have to check for plagiarisms, like Turnitin or any application. So that it is used. And for DNA sequencing, right? The DNA and amino acid sequence is given when the string is matched, like for finding it out for their genetical problems. And spelling check, the patterns, the automa, and whether the spelling is correct or not. If it is wrong, you sometimes you see on your documents on red lines, right? This is the algorithm that runs behind. Search engine, lots of algorithm, like the page rank algorithm, the hits algorithm. Those are the pioneer algorithms that are being used to search from larger database, and how do you categorize it, right? After the session, go and find out what search algorithm Google uses, all right? What that is what you have to apply. See, everything has what algorithm. It's not learning the subject. How you apply the subject, that's very, very important. That's what they're having like guest lectures, like, and then Bellman-Ford algorithm. That it's also the finding the shortest path, but it is slower than, but it's capable of handling negative edges. But shortest path cannot be found if there is going to be a negative cycle onto that, right? And Bellman-Ford is also able to detect the negative cycle. That's a very, very important feature of this Bellman. The best case, we go of E, edges and vertices, vertices into edges, vertices into edges. And complexity when the graph is disconnected. Alright. So where do you apply network routing? Right? How do you route your data packets to different methods, and GPS navigations, right? How do you find the GPS to be navigated? And that you use Google Maps. How many of you use Google Maps? Click on raise hands. How many of you use Google Maps? If you all could keep cameras on, it would be better. Otherwise, it's looking like speaking to computers. Do you use Google Map? Yes or no? Oh, yeah, Shoham, Aditya. I can see they are using. What about others? All right, only two answers. All right. So that uses Bellman-Ford algorithm. Transportation, everything, and logistics, Amazon, Flipkart. I determine the optimal path for Ola, Uber. The gaming, do you play different games? Right? We have an extensive course on gaming development using Python, right? And robotics and autonomous vehicle. All pair shortest path, that's also known as Floyd-Warshall algorithm. To find all pair shortest path, right? How do you generate a matrix from this, from nodes to edges? And I don't think we have much time. So how do you initialize and how do you update every solution, and find from each node how to go to destinations, right? How to go to destinations, and infinity are not found. And as you go on each steps, then you'll be able to find it out which is a determinate node, and then how do you find the shortest path, and then you get your resultant matrix, right? Which is the shortest path to go from each source to all destinations. So here for flight connectivity, if you're going to travel between different places, so when you search on Google Map, you will be finding it out, but algorithm runs behind it. Also, all path shortest path, right? All path shortest path for network routing, geographical information system, and the generalization. Like Clean's algorithm is a generalization of Royal's algorithm, right? And also you've got distribution of LPG gas, right? That has also got Floyd-Marshall algorithm. Also computer networks to find the networking condition. All right, you able to get it? Yes or no? Yes. So we started with the complexities, then we moved on with the different algorithms, right? What are the different algorithms? And then we moved on with the different kinds of the string searches. That was the third part of it. And the fourth part was the graph algorithm. Any doubts till now? I don't know, most of you are not responding. Okay, thank you, Shoham. I don't know whether you're able to understand how things are going on. The next algorithm is a flow algorithm, and how the flow network, it's a directed graph. Whenever you see an arrow mark onto the graph, it's a directed graph. You should have seen when I showed the bottom up approach and top down approach in dynamic programming, right? One is the source that produces materials at a steady rate, and other is the sink which consumes at a constant speed, right? The flow in which so some like how the flow of liquids through pipes, right? Like wires, how the power connections and deliveries of goods uses flow models. So it's a directed graph with wedges, vertices and edges. On each we have a non-negative weight capacity. So it's a weighted graph. All right. From source to destination. Source is S, the sink is T. So this is how the algorithm works with capacity. What is the capacity of it? What's the skewness, the distribution of data, and what is the flow conservation? All right. So this is the value of it, how you take your flow from your network and how it is being from the source. It should keep on reproducing, and at the sink, and also you can use it for inventories, right? Inventory applications. So maximum flow application for destroying for network connectivity, bipartite matching, for lower bound, upper bound, for census tabulations, for airline scheduling, image segmentation on disease or anything, right? Project selection and baseball elimination, right? And it is used to solve lot of fault function algorithm. Also is used in the flow network, right? So finding the augmenting path from the source to destination. How do you start off with? I'm not going deep into the algorithm. Where you can use it, like for image segmentation, for network routing, for supply chain, especially in transportation and distribution. Electricity distribution, how does the electricity is manufactured and how it is being done. Traffic, right? You see in Google Map, there's a block you can put it on, like traffic management. Water distribution, and Chennai's water distribution also you can see to it. The next is advanced CIRF algorithm. This is also just an implementation of the BFS, right? Breadth first search, and also it is used for finding augmented path, right? So this is what it is used for, the time complexity and the space complexity of it. All right. So I'll stop here, right? I'm not going to geometry. Any questions you have? You can let me know. All right. Now let's play a live quiz. I'll give you a link, right? You can click the link and it'll give you your names. I've given the link on the chat. Let's see how many of you are joining and join the quiz. It's just 5 multiple choice questions from the session handle. Yeah, I can see Manasa joined. I hope you're able to see in the screen. Others quickly join. Yeah, Shoham has joined. Yes, Lokesh. Yeah, 7 of them have joined. Yeah, good people are joining. Yes, 13 have joined. Still more? Let's begin. Yeah, 15 have joined. Good. Let's play. What type of theory does algorithm analysis belong to? Yes. Yes, complexities, right? The answer is complexity. Very good. 89 of you have given the right answer. Ah, the first place, see the name they have given. Guess who? You have to tell me who are you. How will I know? Answers on the chat. Who's the first person? Second is Aditya. Third place is Lokesh, Shaham, and Viber. Let's see who's the guess who. You have to tell me. I don't know. All right, let's move on to the second question. What approach is found in divide and conquer? Top down, bottom up, linear, or random? The right answer is top down. 64 of you have given the right answer. And again, it is guess who? I don't know who you are, and you have to tell me who you are. Lokesh, very good. Aditya, Ranjit, and Yashwant. Thank you. Let's go to the third question. What is compared in native pattern searching, in the string searching algorithm we saw? Patterns and input, patterns and variables, patterns and strings and numbers. In name based, it's patterns and input. Very well. Most of you have given the right answer, and guess who is still on the first place? All right. Which algorithm is guaranteed to find shortest path? Similar to Jigsaw, is Bellman or Prim's or Prisker or Flyout? Answers on the chat, please. Sorry, answers on the Slido. And the right answer is Bellman 4. Most of you have given the right. Again, it is guess who? Okay, Lokesh, Vaibhav, and Ranjit and Nisha. Thank you. The final question that is going to decide who is the winner of the day. What type of path does Ford-Fluxon algorithm iteratively finds? Is it shortest path or augmented path or longest path or cyclic path? Ford-Fluxon finds the augmented path. So in the first place, it's guess who? I don't know who it is. I want you to give your answer. Who is the person on the chat, please? Second place, and it's Lokesh. Congratulations, Lokesh. Vaibhav, Ranjit, and Aditya. Congratulations. Right. Thank you all for joining uh, the session. Uh, any questions? You can. Who's guess who? Who's guess who? You can put your name on the chat or you can unmute and speak. Congratulations. I'm not able to even congratulate because I don't know your name. Any questions? All right. So how was the session all about? You can scan, and if you can give us the review of the session. How was this useful for you? Whether you are able to understand, or it was at least give like 3 learnings that you've done today. You can give your name, your thing, and then I'll give the link on the chat, right? I'll give you a few minutes so that you can put it on to that. You just click the link. How was the session all about? What are your 3 learnings? Have you got the link? Yes, on the chat. Or you can also scan. Who is guess who? We have few minutes before I leave. If you could tell, it will be easier. All right, was the session useful for you? All right. So thank you so much. I'll share my details. Right, you can visit the website, and you want any more collaborations with us, you can connect Indra ma'am or Omana ma'am. All right. Some of the sessions are on YouTube channel. You can find it out. Subscribe to the channel. Kindly do subscribe. It's not anything for purposes, but you can find it, right? Lot of resources on AI, ML, because basically I'm a data scientist I work on. And these are the different links on Instagram and LinkedIn. You can follow us on LinkedIn so that any sessions that we handle will be posted onto that and it can be of good use, right? So you can find whatever the events, right? We have got a lot of people working on with us, and you can see what are the tasks that we do at CIRF, right? You can also follow our page onto it. Like people come for IB, internships and workshops and what we do. If there is no more question, thank you, and over to the organizers. Thank you. Sure. Thank you. Bye. Thank you.